The human brain is the most complex structure known to humankind. It is a marvel of biological engineering, a labyrinth of interconnected cells and pathways that govern every aspect of our existence. It's a universe within itself, a vast network of neurons that communicate through intricate patterns of electrical and chemical signals. This symphony of billions of neurons firing in harmony creates the foundation for our thoughts, emotions, and actions. Each neuron, with its unique role, contributes to the grand orchestra of the mind. Understanding how this intricate network operates, how it processes information and generates consciousness, is a monumental task. Scientists and researchers dedicate their lives to deciphering these complex mechanisms. They explore how thoughts, emotions, and actions arise from the interplay of these signals, seeking to unlock the secrets hidden within our neural architecture. This quest to understand the brain is one of the greatest scientific challenges of our time. It requires a multidisciplinary approach, combining insights from biology, chemistry, physics, and computer science. For centuries, philosophers and scientists have pondered the nature of consciousness, delving into the mysteries of how this fleshy organ gives rise to our subjective experiences. They have sought to understand the essence of what it means to be human, to experience the world through the lens of our minds. Today, we stand at the cusp of a new era in neuroscience, where advanced technologies and innovative methodologies are revolutionizing our understanding of the brain. The tools of physics, such as neural models and computer simulations, are being employed to unravel the mysteries of the brain, offering new insights and possibilities for the future of neuroscience.
At its core, the brain is an electrochemical organ. Neurons, the fundamental units of the nervous system, communicate with each other using electrical impulses. These impulses, known as action potentials, are generated by the movement of charged ions across the neuron's membrane. Imagine a wave of electrical activity sweeping down a neuron like a ripple in a pond. This electrical signal, however, is not a flow of electrons like the electricity that powers our homes. Instead, it arises from the movement of ions, primarily sodium and potassium, across the neuron's membrane.
When an action potential reaches the end of a neuron, it triggers the release of chemical messengers called neurotransmitters into the synapse, the tiny gap between two neurons. These neurotransmitters then bind to receptors on the neighboring neuron, initiating a new electrical impulse. This intricate dance of electrical and chemical signaling allows neurons to communicate with each other, forming complex networks that underlie all our thoughts, feelings, and actions. The brain is a symphony of billions of neurons firing in concert, a testament to the power of emergent complexity.
Despite its relatively small size, the human brain is a metabolically expensive organ, consuming a disproportionate amount of the body's energy budget. While it accounts for only about 2% of our body weight, it consumes roughly 20% of our daily energy intake. This energy is primarily used to power the electrical activity of neurons and the maintenance of ion gradients across their membranes. This high energy demand has important implications for understanding brain function. For example, disruptions in energy metabolism have been linked to various neurological disorders, highlighting the crucial role of energy balance in maintaining healthy brain activity.
Section 5. Quantum physics in the brain. In recent years, there has been increasing interest in exploring whether quantum phenomena, which govern the behavior of matter at the atomic and subatomic levels, might play a role in brain function. This intriguing idea suggests that the brain could be operating on principles that are fundamentally different from those of classical physics. While classical physics provides a good description of the macroscopic world, it breaks down at the quantum level, where particles can exist in multiple states simultaneously, superposition, and influence each other instantaneously, regardless of distance, entanglement. These phenomena challenge our traditional understanding of how the universe works and open up new possibilities for how we might understand the brain. Some researchers speculate that these strange quantum effects might be harnessed by the brain to perform computations that are impossible for classical computers, potentially explaining the brain's remarkable efficiency and processing power. For instance, the concept of quantum coherence, where particles are in a state of harmony, could be a key factor in how neurons communicate and process information at incredible speeds. This could mean that our thoughts and consciousness are influenced by quantum processes, making the brain a quantum computer of sorts. The implications of this are profound, suggesting that understanding quantum mechanics could unlock new insights into the nature of consciousness and the human mind. Section 6. Consciousness and quantum effects. One of the most intriguing hypotheses is that consciousness itself might be a manifestation of quantum phenomena in the brain. Proponents of this idea argue that the subjective nature of experience, the feeling of what it's like to be conscious, might be related to the collapse of the quantum wave function, the process by which a quantum system chooses one state from many possibilities. While this remains a highly speculative area of research, it highlights the profound questions that arise when we consider the brain as a physical system governed by the laws of physics.
Section 7. The future of neurophysics. The intersection of physics and neuroscience is a rapidly evolving field with the potential to revolutionize our understanding of the brain. As our tools for probing the brain at ever finer scales improve, we can expect to uncover new and unexpected physical principles at play. From developing new imaging techniques to mapping the brain's connectomy, the complete map of neural connections, to exploring the role of quantum effects, the future of neurophysics promises to be an exciting journey into the uncharted territories of the mind.
Section 8. Ethical implications and future directions. As we delve deeper into the workings of the brain, we must also consider the ethical implications of our growing knowledge. If we can manipulate brain activity with increasing precision, where do we draw the line? How do we ensure that these powerful technologies are used responsibly and ethically? These are not easy questions, but they are questions we must confront as we continue to unravel the mysteries of the human brain. The future of neuroscience is not just about understanding the brain, it's also about understanding ourselves and our place in the universe.
Section 9. Conclusion. The uncharted territories of the mind. The human brain, with its billions of neurons firing in concert, remains one of the greatest mysteries in the universe. Each neuron, a tiny cell, communicates with thousands of others, creating a vast network of connections that give rise to our thoughts, memories, and emotions. This intricate dance of electrical impulses and chemical signals is what makes us who we are. The application of physics to neuroscience offers a powerful new lens through which to view this enigmatic organ. By using advanced imaging techniques and computational models, scientists are beginning to unravel the complex interplay of electrical, chemical, and potentially even quantum phenomena that underlie our mental processes. These discoveries are not just academic. They have profound implications for understanding mental health, developing new treatments for neurological disorders, and even enhancing human cognition. As we continue to explore the uncharted territories of the mind, we can expect to uncover new and unexpected connections between the fundamental laws of physics and the emergent properties of consciousness. This journey is akin to exploring a new frontier, where each discovery opens up new questions and possibilities. The brain's ability to adapt and rewire itself, known as neuroplasticity, is just one example of the remarkable phenomena that scientists are beginning to understand. This journey of discovery promises to not only deepen our understanding of the brain, but also to challenge our very conception of what it means to be human. As we delve deeper into the workings of the mind, we may find that our thoughts and emotions are not just the product of biological processes, but are also influenced by the fundamental forces of the universe. This realization could lead to a new era of human self-awareness and potential, where the boundaries between mind, body, and the cosmos are more interconnected than we ever imagined.